Wait, what did you say? Did you say ready, Alex?
I said, there you go, Alex, computer.
Are you serious?
Alright.
Should we go?
It's rearranging that so we can at least sit in front of your right. So, no worries. Do a couple minutes.
Jason, you know what I need?
Are you going to be here
You know what I
Thursday?
need?
Yes, yeah, and Thursday is the meeting.
Yeah, that's the one I'm wearing gone. So just a heads up, I'm gone Thursday this week. I'm at a math PLC meeting with a bunch of the other math teachers here. So you'll have a sub that day. So what I want to do is today I want to finish notes. Tomorrow we'll do a few notes on a couple different topics that relate to the one we've been working on. And then Thursday will be a work day where you can just work on the homework for it. Does that make sense? That way it's kind of easier on the sub that you guys already know kind of what you're doing and you can just kind of work on whatever you need to. And Ms. Schmidt, you said you're going to be here.
Yep, I'll be here
correct?
Thursday.
So she'll be able to help you out with what we're working on. So today and tomorrow, especially like if Beth gets back tomorrow, somebody needs to help fill her in with at least the chapter we're on, so she's not crazy lost because she's already been gone for a week and a half or 2 weeks almost. So we'll do the best we can with her. All right. Let's go through a couple notes here. We're going to be dealing with section 2.7 still, which is called prime factorization. We started this the other day, so we'd like you to have your notes here. So section 2.7, prime factorization. Now, if you don't remember what the topics we talked about on prime factorization, we talked about prime versus composite numbers, prime numbers, and composite numbers. And our goal was to only use prime numbers. So that's why, composite numbers. So that's kind of why we discussed both topics. And then what we did is we went into this idea of prime factorization. So we went through the method of actually how to work it. Okay, and that's what we did on, I think it was Friday last week. So that was the method. The big thing is it's not a factor tree. It kind of looks like it, but it's not. Factor trees are where you just use every factor. It didn't matter if it's prime or composite. You just made every list of numbers that can multiply into something. Prime factorization is where you're only using the prime numbers, which is kind of different. And so there's that method. Kind of what I was always referring to when we were doing the prime factorization. It kind of looked like a hockey stick or a tube sock. It was kind of long, and you had to circle the prime numbers. And it came back to, could you write your numbers back into what we had? We had expanded form and exponential form. And that's the part that I really want to make sure that we're comfortable with today. So our goal is just to practice a couple, maybe 2 or 3 of them, and then we'll move on to the next topic tomorrow, which is like basically how to use this. That's kind of what we're going to be going into. Okay, questions, comments, concerns?
You said you were going to be gone Thursday, right?
Yes.
And we're learning stuff for Thursday, right?
Yes.
Tomorrow's Wednesday.
Yes. Tomorrow we learn more.
Oh,
Yeah. All right. So, let's go through an example here. Let's see. Let's go with. Let's go with 60. Let's go with 63. Yeah, that'll work. Okay. Now, for the number 63, it's just a digit. The first check that we do when we're doing prime factorization, this method, is we have to use the prime numbers. Well, here's the thing. Maybe I should write down the prime numbers first. So prime numbers. So the prime numbers, if you don't know, we start with the number 2, then we try 5. 2, 3, 5, 7, 11, 13. 17, 19, 23, And there's more. But these are the first primes. Notice the number 1 is not a prime number. Prime numbers are only, when you try to break up like a prime number like the number 2, it's only 2 and the number 1. Or 5 is 5 and the number 1. It's the number itself and the number 1. That's how you do prime. So on this problem here, when we're trying to break this up into what we call prime factorization, what's the first number we should always check in that list?
0. Wait, no.
Sorry?
2.
2. Okay. Will 2 go into 63? No. Why not?
It's odd.
Yeah, it's odd. It's not even. I mean, it ends with a 3. 2's not going into it. Now, we should probably check 3. I believe 3 does, because when you add these two numbers together, you get 9. 3 goes into 9. So, all right, so we definitely have to use 3. 3 for sure. Notice, the prime number goes on this side, and whatever's left goes over here. Whatever's left over. And we're dividing it out. So we're taking 63 and we're dividing by 3. So if we have a calculator, I don't know if it's on there. Do you have it on there?
21.
Yeah, it's 21. Yeah, I know 3 does. 3 does. The list for 3 doesn't go all the way up to 63. I know that. I think the highest list for 3s is up to 36 or something like that. All right, so it is 21. Now, what we have to do is whatever's left over, we have to see if we can split this up further. Now, obviously, like what we talked about Friday, 2 is not going into it. 2 failed already, so we're not going to check 2 again. But we should probably try 3 one more time. 3 times what gives me 21?
7.
3 times 7. Now, once, notice I put 3 here. Right here, is this number prime?
Yes. Yeah.
Yeah, so you can stop. The minute you finally get to a prime number in the right side of what's the leftovers, once you get to a prime number, you're done, and I can circle them. Okay, notice that. The number I'm always working with, like I try 2, 3, 5, 7. Those go on the left side, and whatever's left over is on the right until I get down to that final prime number. I've never seen numbers go higher than 19 or 23 right there. I've never seen that. So that's why I give you that list, that very specific list. All right, but what's the expanded form of this thing written out?
3 to the second power.
That's exponential.
Oh.
But just what are all the different numbers that you see?
3 times 3 times 7.
Yeah, 3 times 3 times 7. That's the expanded form. Then we're going to go down and Cole, what were you saying a little bit ago?
3 to the second power times 7.
Exactly. 3 to the second power, there's 2 3s times 7. These mean the same thing. If you were to type these in a calculator, you'd get the number 63. That's how you know we did it right. Okay. Questions, comments, concerns on prime factorization? Like, this is what I'm going to expect to see on like Thursday when you get homework. I want to see this, that you can break down with this little factor tree or prime factorization tree thing. And I want expanded, and I want the final answer, which is exponential, which you guys are really good at finding. This is the end result, but we have to do this work to get there.
So you have to do that 3
Yeah.
times 3.
Exactly. You have to write that above it and then go one more step. Yeah, because a lot of you like to go from here right to this, which is fine, but you're missing that one extra step in the middle. Okay. Questions, comments, concerns?
Will we get documents if you don't have the first part?
No, I just prefer. I want to know. It'll help us later. So, all right. Questions on the first number? No? Okay, let's do another one here. Let's see. Let's go with 350. I'm going to go big. Okay, so this is my next example. So 350. Okay, again, we're going to try to break this down by prime factorization, only prime numbers. That's what we're trying to go to. Now, if you need a calculator, we got a couple over here. So you can use those on the day we do your homework. So Thursday, you're allowed to use calculators. There's no your factor chart, the multiplication chart won't help. Okay, but for just starting, what number do you go to?
5.
5 and 2. Right? Let's try 2 first. I always start with the first prime numbers. I know 5 will go to, don't get me wrong, but always try the first number first, and if that doesn't work, then go to 3. If 3 doesn't work, try 5. We know that 2 does, for sure. So, okay, let's break down 350. So we're going to go 2 first. So 350 divided by 2.
125. 175.
What thing?
175.
175? Okay. All right. Questions on this so far? Okay. All right. Now we have to keep going, so we're going to go down to the next step. So whatever is left over here. I know for a fact that on 175, 2 doesn't go into it anymore. Okay. 5 will. 3 doesn't, because then I add 5, 7, and 1, you get number 13, 3 is so we're done with 3, so we don't need to worry about that. But 5 will. 5 definitely goes into that. In fact, it goes in there, I believe, 35 times. Let's see, 15, bring down to 2, 5, yeah. So let's see, 35. I'm calculating, let me double check my work. Do it in my head. These are off braces. Just need checking it out. 175 divided by 5, is it 35?
175, yeah.
Yeah, okay. All right, and now, what's the next number we should try?
5 again.
Right, 5 again, because obviously 2 doesn't work because we already exhausted the 2's. 3 didn't work anyway, so we're not trying 3, so we're trying 5 again. 5 times 7. And that's when we know we're done because we ended with a prime number again. It just happened to be a 7, that's just lucky, but these are my prime numbers. So, what's the expanded form of this answer?
2 times 5 times 5 times 6.
Exactly, that's the expanded form. 2 times 5 times 5 times 7.
Do you start with the exponent first or no?
Second?
Do you start with the exponent first or no?
No. Nope. So I just write down the numbers and then I write down the expanded. And now we can do the exponents, right? So what's the exponential form?
2 times 5 to the 7th power times 7.
There you go. That's the exponential form.
And actually, if you divide, if you do it, if you start off with
5,
it ends out.
yeah. So yeah, so that's just something you need to realize. If you don't start with like the number 2, let's say you didn't even notice it, you just start with 5. Eventually, you will get down to all the prime numbers. You will, if you're doing it correctly and you're dividing correctly and you're always putting the prime number on the left and you're writing whatever's left over. Eventually, you will get every number. It may not be in this order, but you will have every prime number when you circle them, so you'll be able to do this form still. I just like to go least to greatest. So I would start with the 2 first, then if that doesn't work, try 3, if 3 doesn't work, try 5. Because it makes the numbers a little bit easier to work with. Okay? Okay, we good so far? Okay, let's try a big number now. Let's try that. Now, I'm going to let you guys work this one, and I'm going to give you calculators. You will definitely need a calculator for this. Johnny, won't there's a dish, you get your own. Would you like one?
Sure, we'll try.
Yeah, all right. See if we can break it down to just the prime numbers. Obviously, you know the numbers to try. I want to see if you guys can do this one on your own. If you can, we're done for the day. Very nice, very easy, because this is exactly what I want to make sure of, that we can review what we did Friday, and that way tomorrow we can move on and get to why we're using this, because this is a kind of a weird technique. Now all I'm going to do is I'm going to go around the room and hopefully you're finding these numbers in order. go to 2 minutes here. Okay, all right. Let's start here. I'm going to start in the this side of the room. So, Sean, what's the first number we should always check?
2.
2. All right. So, did 2 go into it? Yes or no?
Yes.
Yeah.
How many times?
4,000.
4,995.
995. Okay, good. Okay, Hannah, did 2 go into this? This one?
3.
3 did. All right. So, how many times did 3 go in?
1,665.
65. Okay. All right. Let's keep going. So now we're on to Alex. Did 3? Because obviously we're done with 2s. Did 3 go into this number?
Yeah.
Yeah. How many times?
555.
55. All right. Good. All right. So now we're on to Cole. What number goes into this?
I did a different than you guys.
That's fine. So, so did you get down to something like this eventually?
I had 333.
You had 333
Because
here.
the second number I did go 5.
Oh, you did this number by 5.
But
All
I
right.
must have typed in the wrong number.
So that's fine. So you know a 5 will go into this, correct? So 5. So that's 100. That's 111. Okay. And then last. So last here, Jason. What does this also go in? What goes into this number as well?
337.
337. All right, good. So now, I went out of order, right? Because I know, like, Cole, you said you went out of order. You did 5 earlier. That's fine. Now, you still get the same thing, right? That's what I'm trying to show you, is that now that we have my final number here, I'm able to circle them. Able to circle. And 37 is prime. It's one of those numbers that just, nothing goes into 37. It's 137. All right. And so, you did 5 earlier?
Yeah.
Yeah, that's fine. Did you get all these numbers, Beth?
I didn't get the 111.
Yeah, not these numbers. I'm talking about the ones I circled.
Yeah.
Did you get the numbers I circled?
No.
Ooh.
I did 2355.
2, 3, 5.
No, not that one.
Did you get 35?
We should have 2 5s. I think only 1 5 goes into it. Did you divide one?
I think she just wrote down the wrong number.
Oh, okay. All right. Well, that's fine. It didn't have to go in this perfect order because we obviously we went out of order. But now, what's the expanded form of this thing?
Ooh, I got it.
Okay,
Okay.
Alex, say it.
3 times 3 times 3 times 3 times 5. But
times 5 times 37. And now what's the exponential form?
2 times 5.
2 times 3 is the second, or no, 2 third times 5 times 37.
There you go. That's the x-axis. Okay, you are good to go. I'll move these desks back. Does that help you out? Okay, we'll take a look at it some more later. Okay, you can leave your desk. You don't need to move them. I'll move them for you. No worries.